Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Hello everyone, very good morning and good evening. Welcome back. Today onwards, I'm going to discuss about concepts related to the Docker and Kubernetes. Okay, I'm totally switching my context towards the Docker and the Kubernetes, and like today is the first session towards this particular Docker and Kubernetes concepts. Right, so as you know, right, to be expertise on these Docker and Kubernetes, the prerequisite, I meant to say, right, we must be having at least the Linux and AWS some sort of knowledge that will help us to proceed with our today's Docker and the Kubernetes discussions, right? So yeah, I hope you all done the good practice and have got familiarized with the Linux and the AWS concepts, right? And yes, we'll get into the story, right? So believe me, guys, the story that I'm going to narrate start from today, right? Until the Kubernetes gets completed, it will be completely a different thing than what we already know in AWS, and this is going to change the structure of how we are running the applications in the real time. All the process that you have gained so far, right? All the process that you know how a application can run in AWS, right? Be it a load balancer or a auto scaling group or I mean to say the high availability solution, right? So whatever, all the best practices that we followed so far in AWS to run your application to ensure that the application should be highly available, highly secured, auto scalable, right? And the load has to be balanced out. A lot of best practices that we usually follow, right? All those will now get changed it into a different way of implementation when we get into the Kubernetes world. Okay, it's gonna be a little tough to understand how the Kubernetes is changing the game of running deploying or running the applications, but I'll definitely take you guys in a best way to make these things easily understandable, right? And you would need a lot of logical sense and a logical thought process to understand how these Kubernetes concepts are working in order to get through. And believe me, so Kubernetes is the one which is going to give you the job, or which will help you to be good in your career path, right? So of course we need a few other as well, but the Kubernetes is on a top, the mandatory skill that we should be much expertise. The remaining all a kind of, right, the prerequisites are some kind of add-on things, but the Kubernetes is mandate for everyone whoever is working as a be it a DevOps role or a platform role or SRE role or a cloud role even, right? At least some knowledge of Kubernetes is mandatory at the moment, considering the market standards. Okay, you will get to know the reason why I'm spending some time on giving you this some insight about the importance of the Kubernetes, right? While we are speaking about the technical aspects of this case. Being said that, are you guys are ready to get started with and see what it is all about and why this is has taken significant importance, right? And why I'm putting some a special note here before I get started with, right? Are we good with this, guys? Can we get started with and walk along through these sessions to get familiarized? Yes, we need definitely a little bit more boosting, right, and more energy to understand these concepts. And yes, we'll walk through one by one slowly. Okay. So since I'm completely changing the game and getting into the different world of story, right? Mostly today I'll spend some time in giving you some thought process and like the reason why I'm going towards the Kubernetes. We should understand all those concepts. So maybe I'll spend some theoretical discussion for next 15 to 20 minutes. Then I'll slowly move on to the implementation part as well. So I always recommend you to have a thought process like, right? Let's say when we are introducing any new technology, new tool, PJ, it could be a Kubernetes or it could be any other, right? Always your thought process should be, right? So what are the problems or the challenges that we are facing at this time, and how those challenges are being rectified or being mitigated by introducing a new tool. That is how your thought process should be. Then only you will understand what is exactly bringing in by introducing a new tool, right? So then you will know, right, what use cases that it is going to solve, what problems that it is going to solve. Just focusing on the command syntax, the technical will not be enough. We should also see what kind of the problem that we are having and how we are doing the improvising the things. Agree with me, guys? I think at the end of the day, all of your goal is what? Your goal is to ensure a application should be running on a server and that should be accessible to your end user, whoever is accessing the web app for making, I meant to say, utilizing the services, correct? So your goal is to ensure that the application is running always as expected without having any glitches. For that, whatever is needed, you need to do. It could be like no, creating a server, or it could be installing the softwares on it, or it could be adding the high availability, load balancing, make it more secure, or whatever it is. Correct. And one single statement, I would say that, right? At one single statement, I would say that your goal is to ensure that your application should be highly available, accessible to the end users, right? That's it. Whatever is needed for that, we just need to do all of this, right? So, so running the application and making sure that the application is accessible to the user is very simple, right? Just matter of take one server, install the simple Apache web app, and put your code, and it is working. But what is that we are doing all these times? We are keep on improvising the stuff, correct? Right? So always it's a matter of how we are improving it further and further, and that's how even the market is looking at, right? So now, uh, what are the current problems that we have running your application on a general AWS EC2 server, and why do we need to go into multiple things, right? So let me take you guys to this particular slides, and I'll try to introduce few more terminologies, and we'll move forward. So now I'm going to introduce you a term called environment. Okay, so you can help me, or you can talk to me about the chat window as well, guys, when I'm going through this. My goal is the end user would like to access a web application by going to his public internet browser, right, and access a website. In general, usually any website that you guys are accessing as of today in public internet space, right, will be like www dot and then the website name, correct? That's a general public website will be there. So here I have taken one example like www.edueki.com, which is our one of the tutorial portal, right? Website, right? It can be any website, right? For that matter, right? So the user want to access a website which is www dot, right? Now, what is that I need to do to ensure that this website is working as expected, right? I just need to take one simple EC2 instance and just deploy or install and configure a simple application maybe I'm just going in very less information for now. I don't want to make it more complicated. So let me take a simple Apache web server, right? You install the Apache web server software, and you all know that when you are installing the web server software by running yum install httpd, it also installs some of the dependencies, correct? You all noticed that, right? When you are installing one web app, it is installing some dependencies as well, right? So somehow you install the dependencies, you make this as a web server, you know, copy the code it into default document root folder, maybe a var www.html, then your web server is ready. And usually the web servers or the servers which are actually configured for your business will be in a private subnets to ensure the security aspect. And if that application has to be accessible to the public internet space, and obviously we need to create a load balancer in the public subnet, then the end user's request will come to a load balancer. From there, the request will be routed to your backend server. There is a general minimal uh, setup that you need to do to make a web app is live and accessible, right? I'm not making it more complicated by adding the route 53. We need to add a record, all these things. We can assume that, right? The domain name, right? The www dot will be resoluting it into load balancer endpoint based on your settings, right? Good. And I'm not introducing like auto scaling, multiple servers, high availability, all these things, which is easily to understand the things. It's a simple thing. Okay. Now the problem that I talk about, or the question for you guys at this time, right? Let's say currently the website is working fine and everything is good, and now I wanted to do some changes to my website, right? It's all uh, practice, right? Day-to-day practice. I meant to say, when you are accessing any website, right, down the line after a few days, your website will be changing. It could be a layout change. It could be a new tabs are introduced. It could be a new drop down, or it could be a color change, logo change. Some features are added, correct? So that means what your website is keep on modifying with the newest features and newest updates to give you more services to the end user. How that is happening? The developer who is writing the code for your website, they are keep on changing the code to introduce a more beautiful features or improving the web experience to the users, right? So now tell me guys, right? So today the website is working as expected. Now the developer says that, hey, I wrote a new code. I made some changes to the code to make it more beautiful. Now, what is your goal, guys, to ensure that the latest code is being applied and that is started serving the new features to the users? It's your responsibility to take the code from developers and keep it in the respective target folder where the code supposed to be, correct? Or from which folder your application is picking up and serving that code to the end users in a browser, right? Or whoever is calling the web app. It's your responsibility to take the code and put into the right place. Agree with me? Maybe just to understand more precisely, maybe a index.html code that you get it from developer, you keep it in the var www.html location, then that will be serving the website. So each time when you get a latest code from developer by doing some changes, yes, you need to copy that it into a target folder, right? So now the question is, the exact question is, let's say the developer has given you the code. Now you take the code and you keep it in the right location where it's supposed to be. And definitely when someone is accessing www.edwiki.com, right, the new code will be get served. But now the question is, um, what is the guarantee that the new code that you have taken from developer will be in a working state? What is the case after you have copied the new code it into the right location, and the users are complaining that hey, and we are not getting the right website in this www dot, the website is not working, tab is not working, login is not working. Possible, right? If the code is not written correctly, and that is actually impacting the end customers, whoever is accessing my website, correct? Being said that, usually we don't need to serve a bad website or a buggy website, right? Or buggy application to the end users. The end users should have a cleaner working web app for a great experience or to improve your business credibility, whatever it is, right? So now, how do you ensure that the code that is being given by the developer is actually a working code before you deploy, or before you put into your target folder, in which folder it's supposed to be, and who is responsible for that? First of all, right? Let's say the developer has given the code, hey, DevOps engineer, please take this code and put into the server. Before you putting the code it into the right server at a right place, right? Who will ensure, or who is the responsibility to test the code and verify that the code is working as expected? Then you copy it into the right place, correct? Definitely the code has to be tested, right? If you are not testing the code, if that is works or not, if you blindly believe the developer and put it into the right server, and that is causing the impact for whatever the reason, and that is bringing down your business from the customer's standpoint, right? So that's the reason now I don't want the code to be get put into my server where it is serving the application to my end business, right? So that's the reason what I always recommend is to have the multi environment. In the sense, what I do is I'll have one EC2 server which is configured as a web server, let's say, right? And I'm having one load balancer as well to serve the traffic to that server. If you see this load balancer is now actually deployed it into a internal facing. That means the load balancer also will be accessible within your VPC range, not from outside of the public internet space. Now I will go to my DNS concept. I will create a record, right, for a domain name, or for a no for a name called, or resource name called dev dot and your website name like dev.edwiki.com. That means I'll go to the DNS, I'll add a record saying dev.edwiki.com. That name has to be resoluted it into a specific load balancer, which is the internal load balancer at this time, and that will be serving the traffic to the backend server. Now the dev.edwiki.com, that URL is called as a developer URL or a developer application, right? And uh, the infrastructure that you have used to serve this developer website is called as a dev infrastructure. At overall, right, this is called as a dev environment. What does it mean by the dev environment? In the sense, I have got one infrastructure ready to run your code and make the application live, but this environment, this infrastructure is only for the developer purpose. When the developer is writing the code, first of all the developer has to ensure that the code is working as expected from the developer's standpoint, right? So where do the developer will be testing the code from the developer side? They can't simply write a file and give it to the DevOps engineer, take the code, right? Developer has to do some kind of a testing as well if my code works or not from the coding side of best practices. So now when you prepare a infrastructure which will be a dev environment, I call it as, then I'll give this to my developers. Hey developers, whenever you are writing the code, right, you please use this respect to dev environment infrastructure, which is like your EC2 server, load balancer, whatnot, right? Then whatever the code that you develop, could you please deploy that code it into the dev web server, which will be accessible by the dev load balancer by a dev.edwiki.com website or URL. Then you verify the website is working fine or not. Once the dev.edwiki.com, right, this website will not be accessible from the public internet space, right? If you go to the public browser and try to run dev.edwiki.com, it won't work. Why it won't work? Because the corresponding load balancer, if you see, right, that load balancer is created as a internal load balancer, and obviously that will not be accessible from the internet directly, right? So that's how. So I'm ensuring that the dev URL should be accessible within the VPC specific. That means within the company specific, internally to my employees only. So the developer will write a code. The code will be get copied into the developer server, and no, we will go to this dev URL, verify the website is working or not. If all good, then the developer will give the sign off or approval. In the sense, the developer says that, hey, I'm done with my code, it's all ready, I have verified the code is working in my dev environment. That's the terminology. Now it's the time to take this code and proceed with your next step, right? When the developer confirms that the code is working as expected, we should not take this code directly into the real environment, right? We need to create a one more set of infrastructure, right, which is now called as a testing environment or a QA environment, which is the quality testing or quality analysis, whatever you call it as, right? What do? Again, you create another EC2 server, you configure that as a web server, and you create another load balancer for that to route the traffic, which is again a internal. You go to the DNS and add a one more record saying that, let's say qa.edwiki.com, pointing that to the specific load balancer, right? Now you inform to you, in the sense, basically creating a server and creating the load balancer. This is all you guys will be doing, right, as a cloud engineer or maybe a DevOps engineer kind of, right? So once this QA environment is ready, right, this environment we will be giving to the quality team or the testing team, saying that, hey, whenever the developer says that they are done with the dev environment and they are confirmed that the code is working because they have tested the code on the dev server, now take the same code and put that into a QA server and verify the code, that application on qa.edwiki.com. What this QA team will do, this is a different team, right? The QA team will be doing the testing part here. You may be asking me now, the testing is already done by the developer also, but what is that the QA is doing here? The developer is always be focusing towards the code best practices perspective. Whether am I writing the code by following the code standards or not, and he will ensure that the functionality is working as expected or not, but he will not, worry much about the different use cases, how it is working. The quality team is the now responsible guy to test this properly. This guy will actually, go to this qa.edwiki.com, right? They will verify whether the login is working or not, sign out is working or not, registration is working or not, the color is coming as expected or not, whatnot. Every aspect they will be testing. If any issues during the testing, let's say the website, someone is logging in, login is not working, these guys will be complaining back to the developers, hey, looks like your code is not working, I verified it, you please check it once and make a fix. Again, the developer has to make a fix. The developer will put the latest code it into the dev environment, he will verify and again confirm that, yes, now I have fixed it, I verified it, you take care of. Again, the QA team will take the code, will put it into the web server, QA server, verify, test it. That's how it works. Once the quality team confirms that the code is working as expected, the website is running fine as expected, then the quality team or the QA team will be giving the sign off. Sign off in the sense they confirm that yes, this all looks good. Then you take the same code, whatever is being confirmed by the QA team, you put that code it into a one more environment called as a performance environment. Simply call it as a perf environment. Why again a perf environment here? When I say environment, in the sense the identical infrastructure components that you are creating just to test out your code on some specific. When the quality team says that the code is working fine, but let's say the quality team says that the login is working and I'm able to see a web page or a image. Login is working. Let's say I'm able to access my video. The video is playing based on the purpose of the website, right? But we need to ensure in the real time, maybe if one person is accessing the website, able to play the video. But what is the case in real time if multiple thousands of people are trying to access my website? Will that be working in the same fashion? Even multiple users are accessing the web application, correct? So that is where the performance will come into the picture. There is a team called a performance team who will be now responsible to perform a perf test or load test. What these guys will do, the same code will be get deployed. When I say deploy, the deploy terminology means copying that code it into the target location where the code is supposed to be. That process is called as a deploy, right? So the code will be get deployed it into the perf web server now. Now will inform to performance team. The performance team will do some validation. They know how to do that. Usually the performance team will be using some performance tools. They will try to mimic the scenario. Like if a 10,000 people are accessing the website, how it is performing? Is it going very slow or expected performance, right? That's how they will be doing the analysis by increasing the number of users load, right? Then they will come up with a strategy. These guys usually tell that, hey, you all know, right? When the users are increasing who are accessing my website, the required compute will go, utilization will go high, right? Processor or memory, correct? So the performance team will basically give some kind of a guidelines that if your server is running with this much of compute and the memory capacity, then this is good to serve this many number of web users or application users. Like that, they give some strategy or some numbers basically. Right now, you need to take this performance team recommendations into consideration, and you create a next environment with the with the recommendations. Let's say the performance team says that, hey, look like we need a EC2 server with a 2 processor and 2 GB memory as an example, right? If that is the case, then only it can serve at least 10,000 concurrent users. Then you put the same capacity and create a one more server, one more environment, which we call it as a staging environment. In the staging, this is the final thing, right? So finally, let me verify my website is working or not as expected, right? With all the considerations that are being done and recommended by the previous environment. Once the code is tested fine in the staging environment, then that is a confirmation that the code is working good. Then it is moving to the next environment, which is called as a production. The infrastructure or the environment where you are exactly deploying the code which is serving the application to the real end users. You see this term, the last one, which is started with www, right? That means what? This is actually a production environment, we call it as. That means the www.edueki.com is the real URL that the people are using. Hence the reason my corresponding load balancer also a public load balancer, and it is serving the traffic to the backend web server. So that means when the code is written by the developer, the code is actually moving it into multiple servers or multiple environments before we get that it into a production. Why do all this? Just to ensure that everything is being checked before we deploy it into the production, because once the code is in production environment, I don't want any kind of the hiccups in terms of accessing the web app. Are you guys following me? So this is more of the process side of it, right? So technically it's just matter of creating a server and the load balancer and deploy the code, right? But this is all about the process, right? And why do I need to create multiple servers as a multiple environments here? Just to make these environments are isolated, right? So the dev team is actually using their own infrastructure or their own environment for a developing purpose. The same way the QA, puff, and stays, the code is actually promoted from one environment to another environment. Can I use a terminology called promotion here? Definitely, right? When I say promotion, right, the code is being promoted from dev to QA to puff to stays, then to the production. That's my final stays. Whenever, right, in order to make this whole happen, right, it's not like one guy is sitting and doing everything. We have a developer team, we have a quality team, we have a performance team, we have a the team who will handle the staging and the production, and we have a DevOps engineer, and even we will be having a SRE engineer as well. In general, if you are in confusion between SRE and DevOps engineer, both two different teams basically in a real time, just to give you one insight. In general, the SRE team who is responsible in creating this infrastructure, they will go and create a servers, right? They will go and create a dev servers, QA servers, puff servers, and staging and production servers. Then the DevOps engineer is now responsible to promote the code it into multiple environments and keep it in production and run it. And I say promotion, what does it mean, guys? Once the dev team says that, hey, my code is working fine, take the code, deploy to QA. One QA says that this is all good, take the code, put into puff. Once you get a sign off, take the code, put into stage, then to production. It's not so easy to take the code and put into a different environment. There's a process is involved. We'll definitely talk about all those things, but that's how multiple teams are putting effort here to ensure that the production is all healthy. And if the production is healthy, that means the end customer, whoever is accessing my application, will be happy, and that makes my business too. Right? And the environment that I'm talking about here will pretty much be standard in every project in every companies. The only difference could be, right, or the side effect of this. Of course, the process is very good. The side effect of this is, let's say the code is ready, I wanted to run a website. Because of this multiple environments, right, the costing is going high, correct? If you take only one server, use it as a production, you deploy the code there, you need to pay for only one server, right? just because of the multiple environments here to ensure that the code is being verified in all the levels from different aspects. Now you see guys, for how many servers that I need to pay now, right? I need to pay for dev infrastructure, QA, perf, stage, then the production. The costing will go high, correct? Costing will go high, maintenance will go high, right? And obviously the administration has to be little more. The engineer has to put more effort in managing and balancing out all these infrastructures. So in comes some companies, right, just to avoid this costing things and all based on the use case, they may go with the dev environment just to verify the code is working good or not. Then they will directly go to the production. They will not use QA, perf and stage and all just to avoid the costing. Sometimes the people will use dev, then go to QA, verify it, then go to production directly. Some may go to dev, then to a QA, perf, from perf directly to production. Possible. So that is case to case basis, right? How many number of environments that the people are using, it's up to their company, their criticality. Because some customers says that my website should be clean, should not have any issues, no matter what is the cost that I wanted to spend. Credibility issue. Some people says that that's okay, we can't spend much. If some issue on my website when my real customers are accessing, that's okay, I'll go and fix it later also. You got me right? It's all criticality basis, how much that they wanted to spend. So I'm just giving the explanation here because we should not be in a assumption that every project will have dev, QA, per stage production. No. So it may vary, but at a bare minimum, definitely dev will be there and production will be there. In between these, like optional based on the situations. Are we good with this? So actually I'm solving one problem. The problem is like whenever I get a code from developer, I can't or I should not keep the code into production directly because we don't know the code is working or not, right? Hence the reason I started off introducing the environments, right? This is good, but there is a problem here. Whenever you are having multiple environments like this, okay, as an example, the developer team is deployed the, I mean to say the code is deployed it into the dev server. The dev team is tested. It is all working fine. Now the code will be promoted. Now the code is deployed it into the QA, right? And the QA team is telling that no, the code is not working. Website is not working. It's not running at all. Possible. Why the same code is working in dev and why it is not in QA? What makes difference here, guys? When I say dev and QA, the only difference here is the infrastructure got changed, correct? The server is got changed. The dev, the code is running in one EC2 instance. When it comes to a QA, it is a different EC2 server. Possibly, right? Possibly the packages that were installed in the dev web server or may not be the same in the QA server where the code is being tested by the quality team. Possible, right? Sometimes, let's say in the dev, the EC2 server might have been created with Amazon 2023 AMI as an example, and maybe it is working fine, right? And in the dev, let's say the Apache HTTPD installed with a version called no, maybe 2.5, and it is working. When it comes to the QA, the EC2 server may be Amazon 2022, Amazon Linux 2. Maybe the HTTPD version is different, possible. The code may not be compatible to the applications or the dependencies or maybe the operating system that is being used in the QA. Maybe it is compatible on dev, possible. That time the QA team will be complaining that, hey, the code is not working. The developer always says that, no, it is working because I have tested it. What's the problem, guys? The problem here is whenever you are promoting the code from one environment to another environment to test it in different aspects, just because of the infrastructure and the application configuration is not identical, possibly you end up having the issues that the code is not working in different environment. So to ensure that everything is being at a same expectation, right, it's our responsibility to keep all these environments it into a identical, at least from the application configuration perspective, or the versions, or the packages, maybe a operating system, everything should be identical everywhere. Then only the code that is running in dev will definitely run in QA, can definitely run in perf stage towards the production. If you are making some changes, possibly it will not run. Let's say dev, QA, perf stage, all these 4 EC2 instances running with one operating system. Let's say production is running with a different operating system. Is that the good practice, guys? No, right? What will happen? Maybe the code works in all the non-production environment. I'm introducing one more new terminology. The code may work in non-production environments up to the stage. You have a confidence that the code is good, but the moment when you keep it in production, it is not working. It makes difference. So I'm using the terminology called configuration inconsistency. Okay, that's the term. So because of the configuration inconsistency between the environment to environment, right? So the code may not work as expected. So it's our responsibility to keep the configuration as consistent. Again, configuration means what? Maybe a package version, OS version, application version, whatnot. You need to ensure that the configuration should be consistent across all the environment, but you don't need to worry about the compute, I mean to say, the compute requirement changes. That means the dev may be running with a 2 processor and 2 GB memory. QA may run with 1 GB, 1 memory, uh, 1 processor, 1 GB memory. Let's say the perf may run with 5 processors, 10 GB memory, so on, so on, so on, so on. Will that makes any effect or issue for us, guys? Having a different compute sizing capacity in each and every environment, will that cause any impact? I'm trying to make this a little more detailed, that whenever I'm looking for the configuration consistency between the environment, the one is the operating system level configuration, which is like your package version, application version, OS version, so on, so on. The second one is the infrastructure compute requirement, like how much processor that I am giving, how much memory that I am giving, these things. Most likely, you don't need to worry about the processor and memory differentiations between environment to environment, because that is just matter of impacting the performance only, right? So it is okay, right? It is okay to have a different computing requirements from one environment to another environment, nothing much impacted, but ensure that at least from the operating system side of world, the configuration, application configuration precisely should be identical across the environment. It's very difficult to maintain the application consistency across the environment, guys. Because today, right, I'll ask you, hey, DevOps engineer, and we are using Apache HTTPD 2.5 version. Okay, you go and install 2.5 version in all the environment. Looks good. Everything is identical. Let's say tomorrow the developer is working on some code changes. He wanted to introduce a one more new feature. When he is working on introducing a one more new feature and making some code changes, let's say assume the new code is required Apache HTTPD 2.8 version, because whatever he is doing the changes, right, that is not compatible with the 2.5, maybe on 2.8. What he do? He will try to make the dev into 2.8 version of web server, and code is developed, tested, working fine. Now the dev team says that, hey, I am done with my code changes, it's ready. You take the code, you put into you put into a QA environment, and now it is failing. Why it is failing? Because in this scenario, the dev is running with the 2.8 HTTPD, QA is running with the 2.5 only. Got me? Why it is? Because the dev side, the version is actually upgraded to be compatible with the latest version. Maybe the developer will not tell you, hey, I'm using 2.8 version. He will just simply says that the code is ready, take it. You take the code, put into QA, it's not working. You go back to developer, hey, it's not working. We'll spend some time, then figure it out that I'm using 2.8 version. You please upgrade in QA server as well. Got me, guys? The back and forth discussions, miscommunications, many things. So when the upgrades are keep on happening to be compatible with the latest features, at one point in time, right, the dev may be running with a 2.8, QA may be 2.5, production may be 2.2, possible. It always happens, and we will be in a confusion now. What's happening? How to maintain the consistency? All these things. So to overcome all these problems that we see here, like how to maintain the configuration consistency, and how to make these things a smoother process. When dev says that I'm ready, how easily we can take that code and move or promote it into the higher environment without causing any configuration inconsistency issues. That is where we are introducing a containerization technology now. Containerization technology, which is a basic for us now to understand, and then onwards we will be moving towards the Kubernetes, guys. For now, the reason why I'm going towards the containerization is to solve one problem, which is the application configuration inconsistency that is causing across the environment, that easily can be solvable by introducing the container technology. Are we good with this? We'll see what is this containerization technology, how that is solving this problem, all those things. Of course, it is a bunch of theory, but definitely it is needed to understand the process side of world, and why we are putting some significant effort in moving to the next technology, and what kind of the problems that it is solving for us. Make sense, guys? I put some effort in making these presentations to understand the things, guys, or else you can't visualize these things just like that. Now I have one more slide to make it more better in understanding what is this concept called containerization and how that is working and how that is solving the problem. You cannot understand uh, how this containerization technology is solving the problem right away today itself. It takes some time, guys, because a lot of new terminologies will come into the picture, and at least it takes 2-3 days of time to fully understand it and see the benefits of this containerization technology. Good. So I'll be in a mute for a 30 seconds of time. You can think of and give me any questions on the chat window. If no questions, we'll be proceeding further to the slide and we'll talk more. No questions. Looks good. So just to give you some context, guys, I think if you look at the years back, right, before even this AWS cloud or any other cloud come into the picture, right, the people who used to have their own data centers, which we call it as a on-premises data infrastructure, right? So there usually the physical servers are purchased and kept into their own data centers, right? And keep a operating system on top of the physical server, and then you install your no, required application. Correct? This is very generic. Now you keep your Apache web server, right, and the dependency packages that would be needed to install and run your web server application, right? It has its own operating system, whatnot. This is how it was before, right? So later on, right, the concept has moved towards the virtualization. That means what? A single physical server will now be get virtualized it into multiple servers. I hope you are all aware of or got an idea about the virtualization, right? We don't need to know the deeper in how it works, but at high level, the virtualization is mean that the physical servers are actually, divided it into multiple servers. So each virtual server will be acting as like a separate independent server, though that is not actually a separate server from the physical prospect, right? So it adds more benefits having these virtual servers comparing to using the physical servers directly, right? When you make the physical server it into multiple virtual servers, and each virtual server will have its own operating system. In that operating system, you again go and install your Apache dependencies, right, whatnot, and make it running, right? So most of you already familiar, right? The advantage is comparing from running your application directly on the physical server versus running it in the virtual servers, right? As of today, in general, if you go and create a on-demand EC2 instance in your AWS is actually going and creating a virtual server in their data centers from any one of the physical server, and that virtual server is giving you guys as a EC2 instance, correct? And you take that EC2 instance and you do or whatever you wanted to, right? So now, in order to move forward, the next technology is the containerization technology. So when I'm using this containerization technology to run the application, right, you take the server, let it be a physical or virtual, whatever it is, the concept is same. Of course, we are going to use virtual servers only, but it could be a physical or virtual, either the case, right? So on top of these virtual servers, usually you get one operating system, right? In our case, let's say if you take Amazon Linux, if you take Amazon EC2 instance, which is installed and run with a Amazon Linux operating system, right? As an example, something like this, any OS that you have chosen, right? So now I'm not installing my Apache directly on the operating system that is installed on my virtual server. Rather, on top of this operating system, on top of this virtual server operating system, which is now called as a host operating system, I'm installing a software called container engine, right? The container engine is the software which will be taking care of dividing, or which will be taking care of running your applications in an isolated fashion, right? Called as a container. In simply put, how a physical server is virtualized it into number of virtual servers by using the technology like VMware or a hypervisor. Same way, right? The container engine is a software which will be taking care of creating the multiple containers on top of your host OS. Whenever the containers are created in the each container, I can install and configure the application that you would like to run. In this case, you can see that I have a container running one application. I can have a one more container that is running another application, so on, so on. You can create the number of containers that you wanted to run your application, right? And the container engine is the responsible guy to take care of creating the containers like this and run the applications. Now, the Apache software that you wanted to run or the dependencies that would be needed to run the Apache and the OS that is needed to install the softwares, all of these are now inside your container. That means application A will have its own Apache web server software dependencies and the OS. Application B is in another container, will have its own web server software dependencies and the OS. Application C has its own OS, its own application software dependencies. Like that means, can I use the statement? Every container is now actually acting as like a separate, independent, isolated server which can run its own application in its own operating system. The container engine is responsible software to take care of how to run these different applications in an isolated fashion in a container wrapper. We don't need to worry how that is handling. And simply put, how a physical server is virtualized it into multiple virtual server and how each virtual server is running. Same way, here the container engine taking care of creating it into multiple isolated wrappers and the applications will be running inside that. What makes difference here, guys, compared to uh, the the virtual server architecture to the container architecture? In both cases, more or less same, right? Even in the virtualization concept, you took one server, you divide that server into multiple virtual servers, you run the application. You see now, each virtual server is running with its own Apache application there. Here also the same thing, right? Application A is one, application B is one, application C is one. It's like created into multiple containers and running your application. The biggest change here is when it comes to the virtual server, if you closely observe, right, the physical server has its own operating system. Then you virtualized it into virtual servers. Each virtual server has its own again a operating system. That means what? Total how many operating systems that I'm using in this method? Two, right? Definitely not three, at least. There are two operating systems, right? One OS is at a physical server, one OS is at a virtual server. Are we good with this? Right? One OS at a physical server, one OS at a virtual server. Then in that virtual server operating system, we are actually installing our applications and making the things running. When I say OS, it's actually a kernel, right? at least from the Linux perspective, it is actually a kernel. Let's say one command has to be executed on your virtual server. More or less, it has to use the it has to use the virtual server kernel, virtual server operating system kernel, and it has to depend on the main physical machine, right? Main operating system kernel as well. I meant to say at a high level, we don't need to go in deeper, right? At least if any instructions has to be get executed, right? It has to be done using two kernels, correct? At a high level. One kernel is actually at a virtual server level. The other kernel is actually at a main server or the physical server in this case, which is being virtualized. So the performance will be a little degraded here because it is using the two kernels in this virtualization layer. That will be little improved when it comes to the containerization technology. You just consider that your physical server is actually installed with a container engine. Now you make your containers. Maybe to keep it short, in the virtual servers technology, each virtual server will have its own operating system. That OS is the complete OS along with the kernel. When it comes to the container technology, each container is created. Each container will have its own operating system, but that operating system is called as a minimal operating system. What is it mean by minimal OS? Minimal OS in the sense the OS that doesn't contain a kernel component. Just simply to keep it, the application A is running in one container. That container has a operating system without a kernel. Application B is now running in another container which has a OS in it, but that OS does not have a kernel. So here there is a OS inside a container, but that OS does not have a kernel in it. It has only some important configuration needed to run the application, but not a kernel. The kernel is still come from your main OS only. The container engine know how to map the kernel, how to make it executed at a base level only. What I'm trying to do, that means inside the kernel, sorry, inside the container, there is no kernel component. It is just a operating system required to run the application. What will happen, right? When it comes to the execution part, right, it is not having its own kernel, right? Everything is going and using the same base kernel only. So at overall, the performance will be little improved when your application is running inside a container layer compared to the previous virtualization technology. Okay, out of this whole story, if you understood or don't understood, I wanted to put one summary. The summary is, right, the olden days, the people who are running the applications on physical servers directly, later on it is introduced it into your virtual servers. Later on, now it is a containerized technology. The only biggest advantage is the performance is improved just because the containers are running with the operating system which does not carry any kernel component. So there are no multiple kernel layers at least. Of course, there are many other advantages, but this is one that I wanted to call out. Being said that, now I don't want to run my application directly on my servers. Rather, I wanted to run it inside a container, which is now taken care of by my container engine software. Just one other last slide on this context, guys. You can tell me if you are good with this. So what I'm trying to do here is take one server and install the container engine software and then that will create a containers for us, and in each container I'm going to put up my application there, right? So if you ask me what is container is like one compute engine to run your applications, right? If you ask me what is there inside this container, it is containing the your actual web server or application software packages. It has a minimal OS without a kernel. It has some dependency packages needed to run your web application, and it has a code, like you are keeping your application developers given code into your container in the respective location where it's supposed to be. And if any other required configuration to run a website, right, or your application, that also should be the. So you are trying to ensure that everything whatever is needed from the application perspective to run it, you keep it inside a container. I'll talk about image, all those things later. For now, so whenever you are running the application in a container, right, so usually all these containers are isolated, in the sense the application that is running in one container cannot be seen by another application running in the another container. So that means each container has its own set of softwares that are packed and installed. You can decide one container can have a Amazon OS, the other container may have a CentOS, the other container may have a Ubuntu or whatever the OS that you like it, guys. That means it's one single system, but you have now got the flexibility to use any OS that you wanted to in your containers. But remember, this is a minimal OS. That means it is not containing any kernel component. It is just a OS to support your application to be running. It is possible to stop, restart, and terminate each container without affecting any of other containers. Think of like each container is like a separate server. If you have a separate EC2 server, right, how you can handle that independently? You can stop the server, you can restart the EC2, you can terminate the EC2, right? You go inside the EC2 and run the commands to configure the EC2, correct? Whatever you can do on a single EC2 server without uh, much worry about any other EC2 servers, right? All those operations now can be done inside a container. Why do you need to struggle all these things, guys? Can I do like this at least? Just for understanding for today. So let's say I wanted to have dev, QA, perf, and production, right? All these different environments. Can I do like this? Rather me creating a one EC2 server for dev, one EC2 server for QA, one EC2 server for perf stage production. Can I do like this? I have one EC2 server. In that EC2 server, one container I will use it as a dev, another container I'll use it as a QA, another container I'll use it as a perf, then stage, then the production. Can I do like that? Just a thought process. Think of like each container is equal to a EC2 server. That is how it works. What capabilities that you get in a EC2 server, all those capabilities now you get it inside a container also, though the container is not a real server. That is just a wrapper. The container engine will make the container as a separate server, but not real. So in the diagram, right, there are four containers. So like these four containers are acting as like a four EC2 servers, but not real, right? All these four are running inside the single system. That's the flexibility. So obviously, rather me running with the five EC2 servers, I'll run with only one server, but it has my containers. So that is solving my purpose. Dev, QA, perf, production or completely isolated, running with right different servers, right? My problem is solved. But in this case, the containers. So I don't need to spend more money in running multiple servers, and the administration effect is less, because at the end of the day, how many servers that I need to maintain, guys, from AWS side? From AWS side, maybe I need to maintain only one EC2 server, at least for the today discussion, right? I need to maintain only one EC2 server. I need to pay for only one EC2 server, but I'm able to maintain dev QA per prod as like I have 5 different EC2 servers possible. So the maintenance is less, and the costing is less, right? And one other uh, best thing here is, right, if you go with 5 different EC2 servers altogether, let's say, at least you need to take one processor in each server, correct? So total, if you are taking 5 different EC2 servers, right, for your different environment, you are taking 5 processors at least, right? So the total compute is five processors. When it comes to the container world, it's one server you are making into multiple containers. So assume like you are creating a server with one processor, still you are able to run 5 containers. So rather than spending 5 processors, maybe I'm able to make it out using one processor only. Of course, your container should support the performance, speed, compute requirements, but at least I can make it out, right? It means that maybe in one single statement, right? Usually when you are running the application directly on the virtual servers, there are a high possibility that you are wasting the computing resources. That is what I'm trying to put on. Let's say you are taking a EC2 server with one processor. Are you really using the complete one processor for your application? May not be, no, right? May not be, right? Maybe you are taking a server with one processor. Your application may using maybe 1% of that. The remaining 99% probably you are wasting. You are paying more, and we are not utilizing that 100% of your CPU, right? And that is wasting. Maybe in this case, let's say it is one server, one processor, and we are running with 5 containers. 5 containers in the sense what? Like 5 applications, and that processor is now being shared across all the containers. So the utilization is more optimized. I'm not really wasting the resources here. If you think so, still there is some processor that is left over, you create a one more container, put one more application, and make use of that as well. So that's how it is possible to optimize the compute resources as well compared to your traditional virtual server concept. So regarding the configuration consistency that I wanted to talk about right now, uh, as I said, right, that we will understand once we introduce the concept called image. I'll talk about that image concept a bit later, but that will solve the problem of configuration consistency, because we don't need to go and install manually the required softwares in all these containers. There is a better way to handle. If it is a direct EC2 server, right, you need to go and install it and configure it in all the servers. Now, when it comes to the container world, so the image concept is there, it will make your life easier. We'll definitely talk about that. Okay. So as a summary, guys, I think if I put some notes, right? So because me using the containerization technology to run the application, one advantage is costing, right? It's a cost optimization can be done. The second one is the maintenance, or I'm always comparing with our previous virtual servers concepts. Okay, the maintenance is little low, the performance is good, We are using the optimized compute utilization. We are not wasting the resources here, and it is way better to support the multiple environments to run, and it's very easy to maintain the software consistency across the different containers as well, and how we'll definitely talk about with the concept of image. So you may be wondering now, what is Docker, correct? So usually if you wanted to run your applications into multiple containers, right? You need to install the container engine. That's what I have said some time back, right? Now I'm replacing that container engine terminology with the term called a Docker engine, right? So that means container engine is the terminology, sorry, container engine is the technology which takes care of creating multiple containers for you. But there are multiple companies who are actually developed and offering you this container engine softwares. Docker is one of the organization who is giving you a container engine capabilities to create a containers. Same way, you get a container engine offered by a Red Hat, offered by a IBM, offered by multiple other organizations too. Got me, guys? That means when you are installing the container engine, there you can take care of, or you can choose which company provided container engine software has to be installed here to make these containers running. Got me? Are you going to use the IBM containers, or the Docker containers, or the Red Hat containers, so on, so on, so on, so on. Docker is one of the popular, famous container engine software which will help us to create a containers in an efficient way, effective way, with a lot more advantages compared to any other. Hence, Docker got more famous, and we are discussing about the Docker containers only here by using the Docker engine is installed and configured. Are we good with this? But yeah, as I said, right, it can be a Docker engine, or it could be any other engine software that is offered by other companies as well, who is supporting for this containerization technology. But definitely in 90% it will be a Docker only. That's a well open source and well popular Docker engine software. The biggest question here is right, how would these containers will be created? I'm keep saying that inside the container there will be a operating system, the web server software, dependencies, code, and so on, so on, so on, so on, right? How to create a container? So to create a container, whatever is needed, all those things are packaged it into a image format. It's a single file which we call it as image, right? To create a container, whatever is needed, all those things are kept into a image file format, and that image file is available in a registry called Docker Hub. The Docker company or the Docker organization is maintaining a registry called Docker Hub. In that Docker Hub, they are actually keeping all the images which will be used to, or which will be helping to create these containers, right? So whenever you wanted to create a container, all what you need to do is go to Docker Hub registry website and search for the requirement, and then you download the image that you are liking or based on your requirement, right? And use that image, you pull the image, use that image to create a container. Then whatever is available on that image with the same information, the container will be get created it for you. That means How can you create a container? It's just because of the image, right? Whatever the image that you pulled in, that image will be get extracted, and the image content will be get loaded it into a container. Then the container will be running with your specific needs. If you look at it high level, there's nothing new here. Have you ever tried installing the operating system on your own laptops, guys? At least the people whoever is using the laptop since years will aware of that, right? And the people used to say, hey, I want to install the OS on my laptop. Can you give me the operating system image? Someone will give you the operating system, maybe in a pen drive, maybe in a disk, so on and so on format, right? What is that? That is the image that has a operating system components in it. You take that image, then you install it and you extract it and make it happen, right? Same thing. To run a container, whatever is needed, that is packaged it into a image format and that is available. You go and download that image and run some commands. Your Docker engine know how to extract the image and run it as a container format. Of course, it is possible to get one image from Docker Hub and use it. Sometimes you can also create your own image as well and can push that image back to the Docker Hub possible. You can create your customized images too. Yes, the container will have the operating system as well, which we call it as a minimal OS because that OS has only necessary needed information to run the application, not like a complete OS. The kernel will not be in your OS, that is part of the container. Usually when I say OS, right, OS is the complete OS which has a kernel as well. But here the OS that is inside a container will not be having a kernel. It is just a OS to run your application, no other purpose. So now if you ask me what is Docker, Docker is just a container engine which will help us to create and manage the containers lifecycle, right? And yeah, again, Docker engine, right? If you ask me what is the Docker engine properties, what this Docker engine do? Docker engine will help us to create a container, isolate the container in the sense one container will not be interacted with the other container by default, just to ensure that each container is acting as a separate server altogether. And this Docker engine is responsible to share the processor and memory, any other hardware resources. Let's say your system has no, one processor, right? So 10% of the processor will be given to one container, another 10% will be its second container to third container. So like basically sharing the hardware resources like processor, memory or any other to all of these containers will be done by the Docker engine. Of course, we can control how much that it has to share to my containers based on your requirement it will be doing. And managing the life cycle in the sense stopping the container, starting, restarting, right? All these things are now handled by the Docker engine only, something like that. Well, all right. So that's minimal theoretical discussion, guys, about all these things. So that means by now you should understand that our goal is to run the application inside a container, not on inside a EC2 instance directly. Are we good with that expectation? So maybe it's a good idea to run one simple application just to see how it works. Then we will go a deep dive start from tomorrow. Obviously, I need to have a EC2 server, right? That is true. So let me go and create one simple EC2 server. Then I'll start showing you how to run my application. So I'll go and launch one simple EC2 server which I wanted to use to run my website or web application. So as usual, I'll go and launch the server, choose the OS. I'm going with Amazon Linux 2023 AMI. I'll go with instance type. I'll choose my key pair, right? And let it be the default VPC for now, default storage, and go ahead and launch an instance. Now you will see the difference. So previously, you log into the server and start installing the packages, right? The Apache HTTP, all these things. Let me take this IP. I will log in there. Nowadays, all the applications, right? Nowadays, all the applications are running in the containers only. It's not like this is suitable for one, not suitable for other. No. Nowadays, everything is running in the container world. Okay. Now onwards, we will see the difference, guys. So usually if you wanted to run your application right on the EC2 server, you run minstall HTTPD and go with this, right? Now, no, I don't want to install my application directly on the EC2 server. Rather, on this EC2 server, which we call it as a host OS from now onwards, on this host OS, first I'm going to install what? I'm going to install Docker engine. I'm installing a Docker engine here. The Docker engine will help me to create a containers and run the applications inside a container. So you install the Docker engine, then it will give you the Docker service, systemctl status Docker. It is now available. You need to start the Docker service, systemctl start Docker. There's a typo. Now you verify the status. Now I can see that the Docker service is up and running. Now this Docker will take care of right all this containerization stuff. What is our goal? Our goal is to run a Apache web server application. I wanted to access it from my browser. Same thing, right? Now what I do is to create a container and run the application in the container. The first thing that you need to do is go to hub.docker.com website that is called as a registry where the Docker images are kept in by these Docker people. Go to the Docker Hub website and just for search here. Let's say here I wanted to install and run a Apache web server, correct? So search for your web server application. You got some results. Almost 10,000 results are came in here. So all these are the images that are available for you to work with the Apache. Now I need to spend some time in reading this documentation and see which is the right one for me to go with this. You got me? Usually each image is for a specific application, guys. Based on your requirement, you go and choose the right image which will be useful. Let's say the first one is actually for Apache HTTP web server. The second one is for Apache Tomcat. The third one is Apache Maven, then Apache Zookeeper, Apache Cassandra, Apache Solar, so on, so on, so on, so on. Correct? That means every application, every software, or every tool has its own image here. You go and choose the one which is right for you. So can I say, at least for now, HTTPD is the image name that is right for me at this time, because I wanted to run a Apache HTTP server, correct? So then go and click on the image that you are interested on. This image is actually created, developed by the Docker people. They have published it in the registry. This image will help you to run a Apache HTTP server software. When you look into this image is actually having what? This image has Apache HTTP web server software, minimal OS, dependencies, configuration, everything, whatever is needed to run this Apache HTTP server, right? All those things are already packaged it into this image. You just take this image and use it. All what you need to do is run this command docker pull. This command is going to download this HTTPD image. You can run the command called docker images to see the image that is now downloaded. I can see that the image is downloaded. Now take this image and run the container. Docker run name of my container. Let's say this is my web application. Any name would be fine. Right now you specify the image name. Hey Docker, take this image and run this image content as a application or as a container. Now it's running. Right, it is actually running your Apache HTTP web server. So currently it is foreground, guys. You see the thing. Currently it is foreground. That is okay. Let me do Control C. It is actually running your Apache software. Getting me? Right? It is the Apache software and all the things are already installed in this image, guys. It is just taking this image. Inside the image software is there. It is just starting the software for you. You don't need to run minstall HTTPD. You don't need to run systemctl start HTTPD. You don't need to do any of this. Everything is already set up in this image itself. Getting me? Right? This image has everything inside, whatever is needed to start your application. Just take the image, run it. The application will be started. Let me do Control C. I'm just doing some cleanup, guys. I'll definitely talk about all this. Now let me run one more time. Right? Docker run on the name of the application or name of the container and the image name, right? So I don't want the application to be started on foreground, right? Usually we don't like it. So to run this in a background, we need to use a flag called D. So that way the image content will be taken and will be extracted, will be running as a container, but not as a foreground, as a background, as a daemon, detached mode. So it is giving you one ID. This is called as a container ID. Now, if you see a docker ps command, this command will tell you the container ID. This is the container that is running. This container is running with so and so image. This container is, is created 20 seconds ago and it is up. This container, inside this container, the HTTP web server application is running, which is listening on port number 80, and that's it. You're done. Now your website is running inside this container, guys. This is a container. For you, it is just a ID. But yeah, think of like this container ID is acting as like a separate independent server. Now tell me, I'm saying that the website is now running actually. Okay, where do you think the website is running on my host machine? So can you see that port number? Right on your EC2 server, if you do netstat-tupln, you can't see the port number 80. No, if you try to see systemctl status, right, HTTPD, no, because because the application is not installed, not running on your EC2 server. Where it is running now? It is running inside a container. This is the container ID. In this container ID, the application is actually kept in and it is running over there. It's possible to go inside this container also, right? Let's say now I wanted to go inside a container because that is where my application is running, right? If I wanted to see some settings there and there, I wanted to manage my application, I can go inside a container as well. Hey Docker, I wanted to execute commands inside a container because usually if you run any commands like this, right, ls command pwd, these commands are executed in your host OS. No, I wanted to run commands inside a container to manage my application, right? Docker exec is the command, and let it be a interactive mode, right? And the container ID, and specify the command name, maybe ls command. You see, I'm actually running the ls command here, guys, but this ls command is not running on my host machine. Where it is running? This command is running inside a container as a interactive mode. That is how the syntaxes are there. Now let's say I wanted to know where I am. What is my present working directory inside a container? So inside a container, currently it is in USR local Apache 2 folder, something like this. It's very hard, right? I meant to say, usually you guys know that when the software is installed, there are a lot of things that we need to do, right? Sometimes you go to applications home directory, see the httpd.conf configuration file, look for the logs, verify the settings. Yes or no, guys? All these are the different things that we talked about. How to manage your application, right? If you wanted to do some changes. Now, if your application is not running on the EC2 directly, if it is inside a container, obviously there are certain situations where you need to run a commands inside a container to manage the application, correct? But this is not a good way to run the commands because every time I need to run only one command by giving this exec. Rather, I can say that, hey, can you run the command called /bin/bash? That means it is executing a bash shell of your container. Now you see that I am inside a container. Whatever the shell that I received here, this is the inside a container. Currently, I'm inside a container, guys. I logged into the container in a way. Now, any commands that you are running, these commands are running inside a container. You see, inside a container, currently I am in the root folder. You see, inside a container, currently it has a /dev/etc/home/mnt/root. I'm just trying to show you the structure just to build the confidence that yes, inside a container there is a operating system structure, correct? Is it looking like a uh, your actual EC2 server, guys? Yes, no? Right? I'm inside a container. Now I'm able to do all this. Let's say df command, you see, this is the file system structure inside a container. Everything is inside a container. Whenever you're done with your container things and all, you can do exit command to come out from the container back to your host machine. Now the question is, when I go inside a container, right, and I can see some kind of the operating system structure here. But what is the operating system that is inside a container? Who decided that which OS should be inside a container? Correct. So the image that you have downloaded from the Docker Hub, right? This image is deciding everything. The Docker people is already prepared a image for you. This image is already packaged with a specific OS, specific Apache software, specific dependencies, and some information. When you take this image, it will carry everything, whatever is needed to run the application. That way, you don't need to do anything. Take the image, run the container, it is running. That's it. If you are really interested to know which OS is inside, you have to go through this image, which is prepared by the Docker people, then read the documentation. This documentation will explain you this image is carrying which OS, which Apache HTTP version, right, and which dependencies, how this works, what will be the root folder of your Apache application, all these things. Yes, we need to spend some time, understand the image, and see how we're gonna work on it. A question for you at this moment. Of course, it's all a thought process, guys. Usually, when you are installing any application on your direct EC2 servers, what is the first thing that you should be familiar with? You should be familiar with what will be the home directory of my application, correct? Let's say if you are installing Apache web server, you should know what is the home directory of a web server, where it is installed. In general, it will be /etc/httpd, correct? Right? /etc/http is the location where the Apache related configuration data will be there. Why do you need to worry about that? Maybe that is the location where you can see the configuration file, right? Just to see the settings of that, all these things, correct? If you are installing the application by yourself by running yum install command, then at least you have some, you know, uh, like you can control the installation process, you can control how it has to operate, all these things, right? But in this case, am I installing the Apache software by myself, guys? Did I install this today? No. The image that you are carrying from AWS, sorry, from this Docker Hub, right? This image is bringing you everything, whatever you needed. So if you wanted to know how this application works, right, you need to spend some time in their documentation only. Their documentation says that it is actually a Alpine operating system. Somewhere you can see here. The operating system that is running inside this image or that is packaged into this image is the Alpine operating system, which is one of the lightweighted Debian based or lightweighted Ubuntu based operating system, which is Alpine, right? Inside this, you can see these are the Apache HTTPD image softwares are installed, and you can see that, right? You see somewhere USR local Apache 2, that is the home directory where the Apache software is installed. It cannot be a etc HTTPD because OS is different. Agree with me, guys? If you install Apache web server in the Amazon Linux, probably etc HTTPD, probably var www.html. But in this case, right, it is actually installed on the Alpine Linux. When the OS is differ, all the settings, default locations, files, everything will change, correct? So in the Alpine Linux, how it is installed, how it is configured, we need to see their documentation, understand it, okay, go into that location, right, and see the stuff. In the Alpine Linux, right, if you install the Apache, right, so the index.html file supposed to be in the USR local Apache 2 ht docs folder. Like if it is Imagine Linux, how you get var www.html as the default location where you need to keep your index.html or any code, right? Same way, in this case, the file is different. This is the location where the code supposed to be. How we know all this? We need to see the image documentation, because this image is already built with the pre-installed software packages, and we need to see how it got built in and follow this hierarchy. Whatever the commands that you are running inside a container, all those commands are being executed by the kernel that is provided by the host machine, not by the kernel which is inside a container. Once you go inside this container, right, this container does not have a kernel in it. The commands that you run are being executed, but how it is being executed? The Docker engine is providing the kernel of the host machine. So this kernel is being played around to execute the commands of your containers, not the kernel which is inside a container. No, that's the technology. That's how it makes or your Docker engine takes care of provisioning or sharing the kernel across all the containers. That means the OS configuration is isolated, differentiated, but the kernel is shareable. That's how the technology works. It's a shared kernel across all the containers, but each container has their own operating system isolated configuration. That will help us to have the uh, multi-environment, isolated environments, and all other benefits that we are trying to look at. That's where I said, right, beginning of this today, it's gonna be little different discussion altogether, because understanding this concepts itself will take some time. Now I'm saying that, of course, let me come out from this container. Okay. Now I'm saying that the Apache web server is running actually, right? I'm saying that the Apache web server is running in this container. Can I access this? If the Apache web server is running, right, I should be able to access the website from the browser, right? If I go to browser and just send the request to that IP, I should be able to get the response, correct? But it's not so easy. Why? If your application is running on the EC2, then you take the EC2 IP and allow the port number in the security group, access it. It works straight away. But now the problem is application is running inside a container, not on the EC2. So when you hit a or when you send a request from the browser, the request has to go to EC2 first. From EC2, the request has to go to container. From container, it has to get the response. There is significant processes there. We'll see definitely all those things, how to access the application that is running inside a container, all this in next lecture. For now, that's the story for today, guys. As an overall big lengthy of theoretical discussion, we need to understand that we are improvising the process of not to run the applications directly on the EC2 instances. Rather, we are trying to run the applications inside a container. A single EC2 or single host machine can be get added with multiple containers. Each container will work as like a separate, independent, isolated instance, which you can manage to run a application independently. The Docker engine is the responsible guide to create a multiple containers for you. Each container will have its own operating system without having a kernel. The kernel is always shareable from your host machine itself to execute the commands. Usually to run a container, the required image is already prepared in the Docker Hub registries. Which image is more suitable for your requirement based on which application that you are expecting it to run. Just get that image, run the container. You don't need to install any of the softwares, anything, because those are already installed, pre-packaged it into a image format. They kept it ready. You just take the image, run it. It takes care of running the required software, whichever is there already in the image itself. So that's how it is adding more benefits, and we'll definitely talk about one by one down the line. Right, the whole concept is started today, right? It gonna be taking at least next 3 weeks of time to go and complete the whole discussions until the Kubernetes to get all these different benefits. Right, so the way how it works is if your host machine is the Windows, then you can run the Windows OS inside a container. If your host machine is the Linux, let's say here, if my host OS is a Linux, then all the containers must have the Linux OS only. Any flavored is fine, Ubuntu, CentOS, Red Hat, but it should be a Linux flavored OS only, right? So you cannot have a Windows flavored OS in your containers, being said that your host OS is Linux. So that will not work because it has to use the kernel from backend, right? So if you are using the Linux minimal OS, and that cannot be executing the commands on the Windows base, correct? So that's where it is. So most likely in real time, we will be using the host OS as Linux. We will be using all of your containers in Linux only because Linux is more comfortable, favorable in terms of the DevOps configurations to run the applications. Are we good with this? Any questions, do let me know, or else good for today with a good introduction of these concepts. We'll move forward and make this more interesting.
I have a doubt, sir. I have a doubt. Suppose when you do install na Apache web server, so you install in where www HTML file. Here also, if we pull the HTTPD server, then we will get. Then we doing by Docker exec we go inside the container. Here we have to go into this var www HTML point to put to write the index of the HTML file.
Correct. So whether it is var www HTML or it is USR local Apache to HD docs or it is something else, that is all depends on the OS that you are using. In general, because you are using Amazon Linux operating system to directly install the Apache, and that is where you got a var www HTML. That is not the case always for all the operating systems, right? So in this case, because this image is packaged with the Alpine Linux, in the Alpine Linux operating system, the location where you need to keep your code is USR local Apache to HDDoc. So in this location, the code has to be not on var www HTML. Why the difference? Because the OS is different. Getting me?
Okay.
How do I know? So take this image, the image documentation will help me because we are not actually installing the packages, right? Those are already packaged into this. Whoever has created this image, those guys know that which OS it is, which softwares are installed, how that works. So they made a documentation for you to use. So if you are using this image, follow this documentation, then understand it, how it works, then how to do the configuration. Got me?
Yes, sir.
Sounds good.
So, can we delete an image when the container is running?
Let me try. So Docker images, right? Currently the container is running from this image which was downloaded. Docker RMI, let's say I wanted to delete this, and you see that a conflict. It says that this image is being referenced by a specific container. It's not able to delete it.
Okay.
So we need to stop the container first, right?
Yes. Yes, we need to stop it, and we'll see all those exercises definitely in the next lecture. But yeah, we need to stop the container, which is equivalent to stopping the EC2. Like if you compare it, right? Yes, we can do all these things. We can stop the container, restart the container, delete a container, right? Can do anything and go inside a container, right? So at one liner, like whatever the operations that you did it before on the direct EC2 server, everything you are going to do now also, but in a container. So the process will change.
And will you also teach how to write a Docker file?
Yes, obviously, right? So that is where that's the main focus point.
Instead Docker, we can use ECR also, right? To store the images.
Okay, so not Docker. Yes, instead of Docker Hub, okay, instead of
Sorry,
Docker Hub,
Docker Hub,
we can
yes, sir.
use ECR. So Docker Hub is the registry to keep the images which is being maintained by the Docker organization. Same way, AWS is offering the ECR service to store these images.
But all organizations use ECR only, right? Not
Yes,
Docker Hub, right?
yes.
I think ECR is private. Docker Hub is public.
Oh, excuse me, sir. I have a question. Can we have multiple versions of an image?
Yes, definitely, right. So that's where you can see the tags here, and in the tag section it will tell you that this image is offered in different versions, and it will give you the more details as well. These are the versions. If you go each version, what is that you will be getting in? So you will get all this information here. You see Apache HTTPD 2.4 version, Apache HTTPD 2.4 Alpha, right? 2 Alpha. So different things, right? Sometimes you are interested on a specific version of your Apache software. Just go on the specific version you pick up from here. Then that ensures that inside the image, the required version will be there.
Okay. I think the main reason why we started doing this thing is because on the EC2 server we were not able, or we had some issues with maintaining the code, like the code consistency, as you
Correct.
mentioned. So in this case, if we're using the containers and we don't use the same, the same versions on different environments or on different containers, would that be a conflict?
Exactly. So right. So now the thing is, who is deciding, or who is deciding how? Of course, start from tomorrow. All our lectures are regarding the same only. But yeah, I'm happy to continue the question hour. Whoever is interested on. For your answer, for your question, right? Who is deciding how the container to be? Image, right?
Mm-hmm.
So I'll use the image. I'll create a container that I'll use for dev. I'll create another container that I'll use for QA. I'll create another container that is for just as an example. Now, if I use the same image to create all these containers, of course, one image I can create multiple containers. If I use the same image creating a multiple containers, do you think that these containers will be differentiated from the configuration side?
No, it will be the same.
Definitely, right? It will be identical. That's it. That is how it is solving the problem. So, right? So you take one image and create a container, use it for dev, create a container, use it for QA, create a container, use it for perf. Then you 100% confident that all these are actually identical in terms of the configuration. It will never worry about the host OS. Let's say host OS can be Amazon Linux, can be CentOS, can be any other. I don't care. Why? My application is not at all depending on the host OS. Application is completely relying on the container information which is coming from the image. When the image is same, all the containers are identical. Agree with me?
Yes.
So that is how it is solving the problem. But
Oh,
we'll go in deeper as well later.
all right. Thank you.
Thank you. And answering to a question in the chat window, yes, we can customize our images. We can change the location of the installation file. We can do all of the customization that you wanted to. As of now, I am using the image that is provided by the Docker Hub, and I'm telling that this image will give you the software right on these locations. If you don't like it, yes, we can do the customization as well. We will be doing that customizations down the line, start from tomorrow. We'll talk about all those things, because the default image that the Docker Hub will give us, right, that may be not suitable for my job or my business, right? I wanted to make it little tuning as per my requirement. Yes, we can do all of this. Sounds interesting.
Tomorrow it will be at the same time, right?
Sorry.
The session will be at the same time tomorrow.
Yes, exactly. It will be at the same time.
And the same link.
Yes, it's the same meeting link, same time.
Thank you.
Thank you. I hope you liked the today lecture, guys, and we'll catch up.
Very much.